Hi everyone, this is Mrs. Jackson. This is Chapter 4, Section 1, Part 2. In this video, we're going to look at how to multiply rational expressions. We multiply rational expressions much like we would find the product of rational numbers. And to multiply fractions together, you simply multiply the numerators together, and then you multiply the denominators together. And just like rational numbers, you always want to reduce that fraction in the end. So first, take an example here with just pure numbers. I have 30/4 multiplied by 16/35. Many of you would probably be likely to reduce this first, and maybe some of you would run for a calculator and start multiplying 30 times 16. There's no point in doing that if you have to reduce the fraction in the end. So you might as well start to factor things down. 30, I think, 5 times 6. And when we factor down, you don't have to go all the way down to prime factorization, but maybe just a little. 16, I see 4 times 4. And then in the denominator, we have a 4, and 35, I think 5 times 7. And so we're looking for the common factors that would reduce out, and we do have some. We have a set of 4s here that can be reduced, and we have a set of 5s here that can be reduced. And what's left over, if we don't have any more common factors that can be reduced, then we multiply back together. So 6 times 4 in the numerator would give us 24, and the only thing we have left in the denominator is 7. I want to do one more numerical example here. In this case, we have 3 rational numbers being multiplied together, and I just wanted to point out that if you have a whole number, and we're going to move to whole polynomials, then that is assumed to be over the number 1. And so now if I break this all down, 64, I think 8 times 8, and I've got a 1 up top, and 12, I got a 4 times 3. Of course, commutative property of multiplication means we could put this in any order. On the denominator, I have a 3, and I have, I think, 5 times 2 for the 10. So we're looking for those common factors, and we've got a set of 3s that reduce, and I've got a 4 divided by 2. I'm going to replace that here with the 2, and it looks like that's all we have. So I'm going to button everything back up. I have 64 times 2 on the top, which is 128, and on the denominator I have a 5, so 128 over 5. Before we move to the rational expressions, I wanted to talk about a couple of common student misconceptions. The first one is a biggie. I see it all day long, students confusing cross multiplication with finding the product of fractions. For example, if I said, find me the product of 1/2 and 3/4, so 1/2 times 3/4. Of course, we multiply the numerators and we multiply the denominators. So the product of 1/2 times 3/4 is 3/8. However, what I see students do often is 1/2 times 3/4, and all of a sudden, what do you know? They start doing this. Cross multiplication. Okay, this is 6 over 4. This student who's doing this work is very confused about cross multiplication. This is not correct. So if we're looking at cross multiplication, maybe I'll change colors here. Cross multiplication is inverse operations. They happen over an equal sign. This is critical here. Cross multiplication is when we undo division with multiplication. Those inverse operations are always done across an equal sign. So this is cross multiplication. That is not what we're doing here when we find the product of fractions. The other common misconception that I see often is students incorrectly simplifying a sum in a fraction. For example, if I had 2 plus 8 over 2, if I use my order of operations, I have to simplify the group. A fraction has groups. The numerator is a group and the denominator is a group. So I have to say 2 plus 8 is 10. Divided by 2 is 5. The misconception I see, especially when it's algebraic, is this sort of thing. So, okay, I can cancel these 2's here. They'll reduce to 1. Actually, oftentimes, students will just incorrectly think that goes to 0 and say, okay, this is equal to 8. Another incorrect answer would be 1 plus 8 or 9. So we cannot cross out or reduce anything unless they're products. So if you look up here, everything here is being multiplied together, everything. There is no sum or difference. And so that is a really important point. Don't incorrectly start canceling things when we have sums or differences. Okay, so how do we find the product of rational expressions? Just as we did with rational numbers, we are going to factor everything down first to help us simplify the result in the end. So here we have our first problem. We have one rational expression here being multiplied by another rational expression. As we can see, x squared minus 16 is a difference of squares. So I'm going to rewrite that as x plus 4 times x minus 4. And its denominator is 9 minus x. I'll change colors here. Now I have two quadratics in both the numerator and the denominator. Again, these are easier to factor when a equals 1 because a times c then is just c. So I'm looking for two numbers that multiply together to give you negative 90 and that sum together to give you positive 1. Those numbers would be x plus 10 times x minus 9. You can see here, you could always check. Positive 10x minus 9x is going to give us that plus 1x there. And then in the denominator, we're looking for two numbers that when multiplied together give you 40. And when they sum, they give you 14. So those are pretty easy. X plus 10 times x plus 4. So I'll just say green and blue. All right, so now we're going to multiply the numerators together and the denominators together and then start to simplify. So in the numerator, well, I can start simplifying right away here. I have an x plus 4 and an x plus 4. So here, this pair of factors reduces to 1. And I have an x plus 10 and an x plus 10. They also reduce to 1. So I want you to look very carefully at this, 9 minus x and x minus 9. If I said what would be, for example, 5 divided by its opposite. 5 divided by its opposite is a negative 1. And that's exactly what we have here. X minus 9 and 9 minus x are exactly opposites. It happens to be a algebraic expression instead of a number. So I'm going to put this over here just to point this out. You will see some examples like this. Okay, so these are going to reduce, instead of to 1, they reduce to a negative 1. And we're done. So our final expression left is a negative 1 out front times x minus 4. And you could distribute that negative 1 if you wanted to. Now, what domain do I have to exclude? So as we mentioned earlier, we have to exclude anything that's going to cause a 0 in the denominator. You could see positive 9 will definitely cause a 0, negative 10, and negative 4. So I'm going to need to exclude all of those values. So our domain, if you will, is all real numbers except and I'm going to not write this very often. So we said x cannot equal 9, x cannot equal negative 10, and x cannot equal negative 4. All other values are acceptable. Okay, let's take a look at another example. This time we're going to find the product of 3 rational expressions. The first rational expression, I'm going to put it in blue, cannot be reduced in any way. So I'm just going to rewrite it. And the second one I'll put in green. In the numerator, I can factor out a 3. So I would have x minus 6 remaining there. And in the denominator, I can factor out a 6. And the last one, I'll put in red. I've got an x squared on top. And in the denominator, I can factor out a 4. Okay, so we're looking for anything that can reduce to 1. I have an x plus 3 in the numerator and an x plus 3 in the denominator. They will reduce to 1. I have a 3 in the numerator and a 6 in the denominator. That's going to reduce to 1/2, so there'll be a 2 left down here. And I have an x down here in the denominator and an x squared up here in the numerator. X squared divided by x is going to have me with an x remaining. So I think I've got them all. And now we're going to button everything back up here. What's remaining? So in the numerator, I have an x times an x minus 6 left. And in the denominator, I have a 2 times 4 would give me... Actually, no, I'm sorry. I have this 4 as well. So I've got 4, 4, and 2. That's going to give me 32 times x plus 3 in the denominator. So what values of domain must be excluded? X equals negative 3 will create a 0 in the denominator here and here. So that's easy to spot. But don't forget about this x. So this x right here, if that x were equal to 0, the entire denominator would equal to 0. Anything times 0 is 0. So we have 2 values to exclude. We have x equals 0. And we have x equal negative 3. Okay, I have one remaining example for you, and I'm doing this problem to show you just how really complex some of these problems can get. All right, so we have an expression here, a rational expression on the left, and then we have a polynomial to the right, which we're going to assume is over the number 1. And we've got a lot of factoring to do. So I'm going to start here with this piece. I'll put it in blue. So that we can factor out an x. So I'm going to take an x out, and I'll have x squared minus 4 remaining. And now I'm going to work on this quadratic in the denominator, and that does not have a equal to 1. It has a equal to 6. So this one's going to be a bit of work here. I'll put it over here. So 6x squared minus 13x minus 5. A times c is negative 30. So we're looking for factors of negative 30 that sum to negative 13. There's something about these numbers that everyone wants to use 10 and 3, but because our AC is negative and our B is negative, 10 and 3 will not work. That would either result in a negative 7 or a positive 7. So we're actually looking for 15 and 2. A lot of people get that confused. I don't know why, but I see that phenomenon all the time. We want our 15 to be the negative one because when summed together, we want that negative 13. So you're going to have to factor by grouping. It's kind of a lot of work. We're going to replace our negative 13x with negative 15x plus 2x. I think I'm going to put the positive 2x first to make my factoring by grouping a little bit easier. Okay, so I'm going to take out the greatest common divisor out of the first two terms. I end up with 3x plus 1 remaining. And I'm going to take out a negative 5 out of the second two terms. And I end up with 3x plus 1 remaining. And therefore, I can rewrite this quadratic as 2x minus 5 times 3x plus 1. And so I am going to replace this quadratic with its equivalent expression. So I have 2x minus 5 times 3x plus 1 on the denominator. And over here to the right, I have a trinomial. It looks quadratic, but it's not quite yet. I'm going to put this in red. And again, I'm going to have to factor that. So I'll put this work over here. So I have 2x cubed minus 3x squared minus 5x. And I can see that an x can be taken out of every term. And that will give me 2x squared minus 3x minus 5 left. And I have a quadratic here where a does not equal 1. So I'm going to have to find my factors over here. A times c equals negative 10. And our b equals negative 3. I'm looking for factors of negative 10 that sum to negative 3. And I have negative 5 and positive 2. So I've got my x out front here. I'm going to switch over to brackets. So I have 2x squared plus 2x minus 5x minus 5. Now I'm going to factor by grouping. I still have my x out front. I'm going to take a 2 and an x out of the first two terms. That would give me x plus 1 remaining. And I'm going to factor a negative 5 out of the next two terms. And that will give me an x plus 1 remaining. And so the three factors that this trinomial turns into is x times 2x minus 5 times x plus 1. And so I'm going to put this all over here in red. I have an x. I have a 2x minus 5. And I have an x plus 1 all over 1. And now we're looking for pairs of common factors in the numerator and denominator. So I have a 2x minus 5 can be reduced, and that looks to be about it. So I have an x times an x here, an x times an x. So I might as well button that back together. I have x squared out front. And this x squared minus 4 should have been factored out, and I would have factored it out definitely if I saw anything that could have been reduced in the denominator. But I'm going to go ahead and factor it now. This is x plus 2, x minus 2 in the numerator, and x plus 1. And in the denominator, I have 3x plus 1 left. Now, what values of domain need to be excluded? We're going to find those in these two factors here. So if I put both of these factors equal to 0 and solve, I will see that x cannot equal positive 5/2, and x cannot equal negative 1/3. Either of those two values will result in a 0 in the denominator. And one final thought I want to talk about again is the most common student misconception is incorrectly reducing sums. So for example, if I had 3x plus 6 in the numerator over 3x, this is equivalent to 3x divided by 3x plus 6 divided by 3x. that's equivalent to 1 plus 2 over x. So all of the work that I just did is a correct simplification. So this is correct. What would be incorrect is the following. 3x plus 6. We've got a sum. I cannot do this, for example. I cannot cross 3x over 3x here because they're not listed as factors above. We have a sum. So this I see all day long students doing. This is not correct, so please do not do that. All right, in this video we looked at some pretty complex products of rational expressions, and we see how we have to break everything down into its factors in order to simplify the resulting rational expression. And finally, we need to identify very specific finite values of the domain that must be excluded for the expression to be valid. All right, hope this video helps. Thanks for listening.